everybody. Good that you keep on coming back. Yeah, so there must be either something of value in this room, or it's the lunch that you're gonna get afterwards. But again, it's good, really good to see so many of you all here in the room. We will now go further, a bit more techie. Yeah, so stay with us. We're trying to make it attractive. We've got lots of pictures, etc. So even if you don't fully understand everything that we're saying, the picture shouldn't be too bad. What we're going to be talking about today is really how is the ATM CNS infrastructure doing in the new normal, so to say. And it is not necessarily a nice picture. First of all, data link. We need to squeeze the existing CNS infrastructure and certainly the data link system more. We need to debug all together the final things to really make sure that the technical performance is continuously good for everybody. And then we can start reaping really the operational benefits that we so desperately need to further get some more capacity in the European system. Second, as I said, it's not always a nice place out there. The CNS infrastructure is under, I would say, increasing threat. And some of these threats are, I would nearly say, unintentional or not completely politically driven, etc. But GNSS interference, 5G interference are problems that won't go away out of their own. We need to work this. We need to look at what type of procedures we can put in place to keep it all safe, etc. And you will hear from the experts some more on that. Third, believe it or not, but we have too much CNS infrastructure, way too much, really. And we're not doing ourselves a favor with that. Take the example of the surveillance infrastructure. The sheer fact that we have so many different radars interrogating the aircraft means that we get into a situation of what we call over-interrogation. And the guys will tell you, will show you what that means in terms of an operational impact, but it is basically aircraft disappearing from the ATSCO screens, sometimes whole fleets that don't appear anymore. This is serious business and we need to work all together to improve that situation further. And last but not least, and this is not unique to the aviation system, but we are getting increasingly under attack by the cyber guys, yeah, by the bad boys. They are not necessarily always directly targeting aviation. Sometimes they are with ransomware things for airlines, etc. But sometimes they're just trying it out and they're just trying to see where they can get into the system. Now, the EUROCONTROL EAD was hacked 2 years ago. Yeah, that was not a pleasant experience, I can tell you. No data was corrupted. Nothing happened operationally. That's the good news. But we are increasingly convinced that one moment or another, something big is going to happen in the European ATM infrastructure system. And we need to be extremely vigilant altogether to keep it cyber secure. One of the options, and that's only one of the options, and there's many, is that we work better together and pooling our resources to deliver the efficient services through common procurement. We won't dwell on that too much. That is for other fora, etc. But this session here, we have a very good set of speakers. On data link, we have, first of all, have our program leader, Nikos, with, and I'm very grateful, 2 captains from Wizz Air. Thank you very much for coming to this. We got Gary talking to you more about the navigation interference. We got Petro Jonas talking about the 1030, and again, very grateful to Jürgen from Skies to share their experience with us. And then Patrick Mana, who doesn't know Patrick, I nearly need to say, yeah, we'll say more about cybersecurity. And there we're very grateful for our colleague Eric from Aéroport de Paris, who will also share his experience with all of you. So, yeah, hang on. Yeah, it's getting a bit more techy, but it's still very, very important. Okay, Nikos, the floor is yours.
Thank you, Paul. So what, I suppose all of you, you're having telephones with you, you're using messaging, you're using chatting, and this is very normal. So what I will talk to you about is to try to bring this normality and this very normal case to the aviation world. And myself with Peter and Ben actually will try to show you the aviation efforts on how to bring this normal thing from our daily life into the aviation and to try to see and solve the remaining problems. What I will cover in my presentation is 3 items. I will just provide first a brief update on the deployment status in the European environment. I'll show an overview of the observed performance, and then I will also highlight what NM is doing in terms of data link. So starting with the deployment side, I have actually two slides, and the first slide is focusing on the deployment on the ground side. So what you see here on this picture is a lot of green, and this is the states actually that they have deployed data link. And you hear a lot about data link. So why data link? First of all, there is an implementing rule. There is a law that is requiring to deploy data link in the European airspace. And there is a second law that is also requiring, this is applicable only for the ground, and this is requiring the NSPs to implement the automatic forward of the logon information. These two European laws are very important in order to support data link, and the requirement is to support everywhere in the European environment data link above flight level 285. And you also have, in some cases, data link implemented above some local flight level of implementation. When we're talking about data link, of course, we are interested in the services behind, and there are 4 services. One service is for the pilots to log on, and then we're having 3 services that allow controllers and pilots to transfer communications, to have clearances, and also another important safety service is to check that the push-to-talk button is not accidentally pressed, jamming the frequencies. So you see here on this map that many of the European states have implemented data link. However, we are still having 3 states, 3 NSPs that they are still have not implemented them. The situation also is not very good on the automatic forwarding of the ground. While most of the links are operational and supporting, there are some links that they are still creating some problems. And when the automatic logon is not actually there, then this creates discontinuity that will stop the data link, and that is not allowing for the uniform use of the data link throughout the flight. We're having also a number of operational restrictions. Some of them will go as away, and some that they will need to be implemented by some NSPs, like the use of the logon list. On the bottom of the site, you see also a link to our data link dashboards. So this is on our public website, so you can get up-to-date information on the status of the data link operations in Europe, and also the implementation status. Now, looking on the airborne side, if we had a picture actually to show, that will be more green here. So the situation on the airborne side for the operators is very good. So we're having above, it's about 82% of the flights, they're indicating capability to do data link. And when we're talking about capability, is declaring, having the equipage, but also having trained the crews. And you're going to hear from my colleagues with how important training is in this process. We do have 15% of the flights that they are exempt. And we do have about 2.4% of the flights that operators, we believe they are still misfiling and not filing correctly the data link fields. But some of them, they don't do it on purpose, because there is actually a number of them, they are exempt and they are not filing correctly. We see a small percent, that's about 1% of operators, that they are not really complying with the rule requirement, in the sense that they are not equipped, they are not filing J1, but they do fly above flight level 285. That was tolerated, especially in the COVID period. Now, with the traffic increases, some of the NSPs are coming and requesting maybe some actions, and there is already some discussion potentially about rejecting flight plans that they are not having a declaration of J1 and declaring to flight above flight level 285. What you see on the right-hand bottom side, we have prepared a leaflet as an M, providing information on how to fill the flight plan. So whoever needs more information can contact us on that one. And we have, and that leaflet has been helping a number of cases, operators to sort the problems, and they were not able to log on. Moving now on the second part of the presentation on the performance aspects, we're having every Monday in NM on the Monday afternoon a regular telecon with the different stakeholders to discuss various items, and data link is one of the things that has been discussed. So I chose actually for this presentation two of the slides that we regularly show in this forum. So the first slide, this slide, and I'll start from the top right. On the red table, you see what we call the safety benefits. You see that the pilots and the controllers using data link in the period of 4 weeks in January, we saved close to 8,400 minutes of radio telephony voice time. That means that the voice channels was less congested and prohibiting maybe some overlaps and having to repeat information on the voice channels. And the second line on this table shows what we call the stuck mic events. So we had 74 instances that controllers in the European airspace asked 281 pilots to check if the push to talk button is accidentally pressed. Moving to the figures, on the top side, you see what we call the usage of the data link. So starting from the left side, you see that when the aircraft is logging on, usually the controllers, there is exchanges of data link, and we're having senders ranging from 90, now it is in most of the cases is above 90%. There are some exemptions with some senders that there are some particular issues, but in general, there is a very good rate of doing some data link. And this brings me to the second picture in the middle. This some data link maybe is varying across different NSPs. We're having some on the top, like Germany and MUAC doing close to 2 or above 3 for Germany, 3.4 messages per flight segment. And some of the other senders are having much less. In some cases, due to the airspace, for example, taking Sky Guide there, it is a very smaller space with 2 senders, so sometimes there is not a lot of opportunities to do data link. Also, on the bottom of this graph, you see 2 other pictures. This is showing information about what we call key performance indicators. One addresses the discontinuities of data link, and this is where you see a lot of problems in different senders on the ground. That there is unexpected interruptions of the data link. On the delay side, in general, the picture is much better, so the delay has improved over the last period. The last thing that I want to raise on this graph is on the right bottom side, you see 2 tables, and we regularly provide information for the top senders and the top operators in the European space on the last week in terms of the provider abort, because this is one of the KPIs that is creating a lot of nuisance when it happens, the interruption to the data link. Moving to the second slide in terms of the performance, this is actually focusing on the airborne side. I mentioned before the log on, and this is actually showing the log on rate of the top 40 operators. So you see also here a great variability in general, and you see also with a color code that you see in the middle on the top, there is a good log on rate on average in most of the operators. There are some cases with some operators for good operational reasons that this log on rate is not as high as you see. For example, we're having many operators on the top side, like Jet2, Wizz, EasyJet, Aer Lingus, Eurowings, and also more than close to more than 90%. So that's a very good rate. And we're having some other operators with a smaller log on rate. NM is actually discussing regularly with some of the operators, and we do try to provide guidance. One of the things, and you'll hear that also from Wizz, is information on training and the standard operating procedures is an important tool to make this picture improving. The last slide that I have for you is to summarize the 6 things that NM is doing for data link. So first of all, being the motto also for EUROCONTROL, we are here to support the stakeholders. So we are supporting the operators, the flight crews, we're supporting the NSPs and the controllers, we are supporting the communication service providers, as they're providing the data link service, the DSP. Of course, we're supporting the avionics industry and the airframers, but we also support the institutions, the regulators, the European Union, EASA, and all other institutions. Another important function that we are doing is really to look at the problems when they are reported, to analyze and investigate and try to find the root cause of the issues. And that we do it in close coordination with the stakeholders, with the industry, with the overall community. And we are really trying to facilitate and playing a coordinator role in order to achieve the solutions and then deploy these agreed solutions. Also, in Brittany, we are offering interoperability testing, which is mainly targeted to the operators, the NSPs, but we're also supporting industry. For example, we're doing regularly support for flight tests from Airbus, from Boeing, and also we'll be planning to support Honeywell in the future. We're having two data link groups, the data link performance monitoring group and the data link support group, and we are providing the support and to facilitate and the secretariat for these groups. And you show also this monitoring of the performance and then reporting appropriately to the different stakeholders for information as well as an action. And the last but not least of the point, and this is really one of the things that needed to happen in order to improve the data link, is harmonization. So what we have seen in Europe is we have seen a fragmented implementation and deployment of data link. So we really, if we want, as Paul said, to try to achieve the benefits of the data link, we need to address this significant impeding to using more data link. So we need to address harmonization. And for that, what we're working to provide is some updated guidance material for the controllers and the flight crews for a harmonized operations. At the same time, we also, there has been also on the technical side, different message sets being implemented. So we also try to harmonize the ground deployment on the message set. And we really rely on the support from the users, especially from the NSPs, as well as the operators, in order to achieve this thing. So our plea is, please, let's work together to try to make data link a better experience. I think already people are acknowledging the benefits, but we can definitely provide more benefits. So this concludes my presentation, and I will just, before introducing, before asking Peter and Ben to come here, I will just say why we chose actually also WIZ to present in this forum. So WIZ is one of the top 5 operators that is regularly, almost continuously appearing on this table that I showed you before with the top operators. They're having a very good performance in general. They're having a very good performance, and also they're having really the highest log-on rate among the top operators. So with this, I'll ask Peter and Ben to come present their side.
Thank you very much, Nikos. It's a great pleasure for us to be here. And yes, we will talk about how we implemented CPDLC. My name is Ben Salfadi. Apart from being a pilot, I'm also the Group Digital Transformation and Standardization Manager. And my colleague.
Good morning, everyone. My name is Peter. I'm also captain and the Group Regulatory Policy Manager for the whole Visa Group.
So today we have the following agenda. We have an introduction on how we implemented the system and our road to the successful implementation.
Also, I would like to take a few words about the benefits of using CPDLC.
And we identified areas of improvement.
So as you all know, Wizz Air is an ultra low-cost company. That means we have many basic, simple principles we are adhering to, which allows us to drive to our goal, which is keeping our costs to the lowest levels. One of the key principles we are employing is the single aircraft fleet. That means that we are only operating A320 family aircraft, and we are trying to keep, and we are keeping the set of equipment as uniform as possible. As a result of that, when we started to talk about CPDLC and the implementation of CPDLC, all of our aircraft were coming from the factory, already fitted all the necessary equipment for CPDLC.
Before going live and before introducing this into service, we basically had not too much information about CPDLC, and so therefore we decided to go with a complete entry into service program. This included best documentation and trial scenarios, and also we conducted many trial flights where we tested the different variants of our SOP.
Once the entry into service program has concluded, we have drawn the conclusions, which allowed us to come up with our SOPs, limitations, procedures around CPDLC and the usage of data link for itself. At that time, the coverage was very low. Obviously, this was a system which has just been introduced. So initially, we incorporated this information into OMC, which is route and aerodrome knowledge, because it was very regional. As the coverage started to spread and started to grow, we moved the content from OMC to OMA, and it became a general procedure required and recommended for all the crew members and all the flights. And our SOP elements has been transferred from the initial SOP description into the customized FCOM. So we have the OM manufacturer documentation, and then we are customizing for our usage. So now it's merged into the FCOM as well. With that, Wizz Air went live with CPDLC at 1st of August 2019, which is well ahead of the mandate, which was February 2020. And this was possible because we started way early the preparation, and then everything was planned in due time.
Well, to achieve success, we had to create a successful training program. And this included an e-training, which was scenario-based, and it was very descriptive. And we had every pilot in the company, at the time roughly 1,000 people, they had to do mandatory training, which was done in roughly 2 months. And at the end of the training, they had to do also a test, a multiple choice answer test. This was monitored by the training department, and by the time of the go live, everybody was finished. Now we adopted this course into our company intro training. So now every new joiner in the company still has to do this training. And by the time they get on the line, they are very familiar with the procedures that we have. Also, for the entry into service, we had a quick SOP leaflet provided to the pilots, which was a very good help. We had very positive feedback on that. Also, our crew members, they were quite keen to start using the system at that time because, as Peter mentioned, we already had them in the aircraft. The hardware was there, so they could see the screens every day, but it was all blank. So actually, they took it very well, and they started jumping on it and using the system right from the beginning with lots of motivation.
Regarding CPDLC and our experience, as you know, for 60, 70 years or so, the main communication channel for commercial aviation and aviation itself is voice communication transmitted through quite a disruptive channel, the VHF radio. Only 7% of our voice communication is transferred by the words itself. So you can imagine the effectiveness of this. I believe everybody who is here and who has ever used the radio has a story or two, which they are not so much proud of, that's for sure. Regarding CPDLC, this is a new system. It's a written text, very hard to misinterpret in our opinion, and it allows a very good way of crew coordination. So it's very unlikely that the messages will be lost or misinterpreted. And in the beginning, we thought, as like everybody, when the very beginning of CPDLC usage, that this channel is actually slow. But once we started using it, the SOPs were becoming faster and faster, and the pilots were getting better and better. We realized it's actually a faster, more efficient, and very precise system to use. Therefore, we have concluded into 5 main advantages, which is on your screen. I'm sure that you read already, what we see as a main benefit of CPDLC usage.
Of course, there are always areas of improvement. Because at the time of introduction, we had limited knowledge about CPDLC. We can say that our SOPs are a bit over descriptive at the moment, but this is something that we will address in the near future. And to give some advice to the ANSPs, sometimes we do feel that we do get many unnecessary messages. For example, you can now use the system or on voice communication only, etc. These messages can be a little bit disruptive, and sometimes it's very interesting to see that we do get CPDLC messages about frequency changes, but in the meantime, we also get contacted on voice, and that's a little bit, I'd say, unnecessary. It's kind of like when you send a text message and you also call the receiver to make sure that they got it. So apart from that, it's working quite nicely. And as Nikos also mentioned, there are some holes even in Europe in the coverage. So we do have to log on a couple of times, which can be an increase to our workload. So our conclusion for today is that it's safe, it's simple, and it's easy.
Therefore, we encourage all the ANSPs and all the aircraft operators who hasn't done yet to start using the CPDLC, and for those who are eligible and certified to use, to keep using it more and more and benefit from the advantages.
Thank you very much for your attention.
And as we won't be able to attend the whole afternoon, if you have any questions, you can see an email address of our boss, who is here also, the head of security and standardization. He's more than happy to answer all your emails or forward to them. Thank you.
Thank you very much.
Can I just ask a quick question?
Sure. Where to look?
Yes,
Sorry.
I'm here. I'm here.
Okay.
From Sun Express Airline, my name is Joshkun. And we do have all fleet equipped with the CPDLC equipment, but we have, unfortunately, half of the fleet is banned, is restricted to use it. Maybe some of the responsible here from EUROCONTROL, we won't understand why these fleets are restricted, because when the pilots are trying to use it, and they get communicate, they contact with the ground control. And do you have any like equipment, the fleets equipped but restricted in the Wizz Air fleet?
Regarding Wizz Air, not that I'm aware of. No.
Okay.
So as far as I know, all of our aircraft are capable and using the CPS.
Maybe a question to the specialists in the audience, and why we are restricted, because aircraft is fully equipped for the CPDLC, and we would like to use it as possible as we can, but half of the fleet is, there's a ban list in the EUROCONTROL website. The half of our fleets is banned. Thank you.
Okay, thanks for the question. And there are fora where we can go into much more detail on all these things. It's not a ban list, let that be sure. What I suggest that you take this offline with Nikos, because also what we see is that each geographical area is specific and what they do allow, what they don't allow, etc. So there is not just one rule for everybody in Europe on this, although we are absolutely striving for harmonizing the operating procedures around this. Yeah, so again, Nikos will take this offline with you. Yep. Another question?
Yes, Polish Air Navigation Service Agency. I got one question. You just mentioned that all of your aircraft are equipped with CPDLC. So the question is why some of pilots don't want to connect to the system?
Well, it's hard to answer that question for a few reasons. One of them is that even though the aircraft is equipped, sometimes it can be inoperative. I'm not sure if you see it on the NSP side. I believe you don't. That can be one reason. And of course, like every SOP, you cannot in every SOP or none of the SOPs can describe every situation. And they might be negligent, they might be lazy, I don't know. But for sure, we are constantly and redundantly encouraging our pilots to use it more and more. And I believe we are successful based on the numbers. But of course, there is room to improve. We are not at 100%. Maybe that time we will be resting a little bit.
I really would like to indeed compliment, first of all, Wizz Air, because I think you're the highest or one of the highest really in terms of log-on rate around Europe. But also let's not forget there's a bit of a human element to it. If you are as a pilot, frequently flying out of a corner of Europe where the technical performance or the operational support is low, you try it once, you try it twice, you try it 3 times, and then you go like, hey, I got other things to do. Yeah. So it takes time then to rebuild that trust and confidence in the system. Yeah.
Just last few words. I believe the key here is the communication towards your pilot community. So if you see this not happening, then maybe you want to look for the root cause first and eliminate that.
Okay.
And anyway, just like air traffic controller, I ask or force pilot to connect, and then they are connected.
Good. And on that positive note, thank you very much again. Really appreciate that you guys came over to share your experience with them. And again, give them a good applause before we go to the next topic.
Thank you very much. Thank you very much.
Then I think the next presentation is on the 1030, 1090. We'll find out when you click the slide, yeah?
Okay, it will be indeed, yes. So good morning, ladies and gentlemen. My name is Petr Jonáš, and I would like to talk to you about the 1030, 1090 megahertz. I would like to explain why is it important to keep it in mind and to keep it in good shape. So I will do a little bit of introduction and some background on this topic, and then I will hand over to our guest speaker, Jürgen, who will talk about some practical examples of improving on this topic. So why is 1030, 1090 important? It's because it is a critical resource. It's an enabler to nearly all the cooperative surveillance technologies that are in use, be it secondary surveillance radar, all the different flavors, the legacy, the MODES, the military identification friend or foe, multilateration systems, ADSB, and also the airborne collision avoidance systems. All these systems utilize the 1030 and 1090 frequencies for the uplink and the downlink. And then in the middle, we have the ATC or SSR transponder on board the aircraft that is communicating with all these systems and is supporting them. If the transponder is not working for whatever reason, there is no cooperative surveillance, and you don't see the aircraft unless, of course, you have a primary radar, but the TCAS also would not see the aircraft any longer. In addition, what increases the complexity of the system is the need for backward compatibility. So all these systems needs to be compatible between each other, which increases the complexity and increases the amount of transmissions that need to be made so that the different systems support each other. And this comes with the certain issues that we're facing. It's a collision of messages on both the uplink and the downlink side, is the very high transponder occupancy. And we're also very often in Europe, as Paul already said, asking the transponders to do more than what they were certified for. And then we're really reaching a situation where we might run into risks of completely losing the aircraft, having gaps of detection either for one or even multiple aircraft, reduction of performance, which then creates the need for additional infrastructure investment and creating even more, putting even more sensors in place, which doesn't really help the situation. There is a risk of safety net degradations. I mentioned the TCAS, but there are others. And of course, this also can create a barrier in terms of additional traffic and additional functions to be supported by these systems. Now, how do we assess the health of 1030 and 90 megahertz in Europe? EUROCONTROL, together with ANSPs and with local partners, have deployed a network of receivers. We have currently 70 ground-based monitoring receivers listening to these frequencies, monitoring the transmissions on 1030 to 90 24/7. We're using modern technology. On the hardware side, we're using a highly flexible software-defined radio platforms. And then we're using big data technologies to be able to collect all this information, store it, analyze it, and then to distill some useful information for the uses of this monitoring system. We're using the same type of receiver on board our monitoring flights, because not everything you can do from the ground. What we do from the ground is we use the traffic of opportunity as flying sensors, and we see what the aircraft are transmitting. But there are also other things that the aircraft are receiving, but not necessarily react to. And this needs to be measured as well. So that's why we regularly plan flight monitoring campaigns, and we fly with such monitoring receiver on board an aircraft around Europe to understand the situation as best as we can. Now I would like to talk a little bit about a concrete example of a measurement. So here I'm using the example of enhanced surveillance. I'm sure you're familiar with this, and you're familiar with the tangible benefits that enhanced surveillance is bringing to the controller. There's a lot of useful aircraft parameters like the selected altitude, heading, indicated airspeed, Mach number, and many more that are supported by this. But it's important to understand that this comes at a certain cost. At the cost in terms of the transponder utilization, and at cost in terms of these RF channels occupancies. As a quick example, the selected altitude parameter is extracted on average in core Europe 4 to 5 times per second from each aircraft, and that's much more than what would really need, what would be really needed to support the enhanced surveillance operations. The result of that is the picture on the left. It's a colored heat map of the opportunity traffic, where we listen to the transmissions of this traffic. And wherever you see red, magenta, or blue color, this means the transponder is operating above the level that the transponder has been standardized and certified for. And then we talk about over-interrogation, and you see that these areas are quite large, and they might be even a little bit large in reality, because we do not yet have completely full coverage of the monitoring system everywhere in Europe. And this creates a need for action. In the short term, what we're doing, we're investigating the really bad events, very, very bad over-interrogations, interferences, malfunctions, losses of detection, and things like that, where we investigate as quickly as possible. We try to contact as quickly as possible the relevant parties and fix the issue as soon as possible. Then in the medium term, we're focusing on good configuration of sensors, responsible configuration of sensors. I could summarize that in one sentence: simply don't interrogate what you don't need, don't interrogate what you don't use operationally. For this, we're developing, or we have already published different guideline documents. I would like to highlight the one pertaining to 1030 megahertz management, which talks about the need to manage nationally all the different sensors, all the different interrogators using this frequency, to make sure that the combined load of them is manageable and sustainable. And also, before there is a new transmitter, new interrogator being installed, it is assessed whether the configuration of that sensor is efficient and is sustainable. Then we have in NM the operational excellence program. There is a specific work stream addressing the over-interrogation on 1030, 1090, where we work together with ANSPs, operators, and also military operators on these improvements. And we will have Jürgen in a few moments presenting some examples of such improvements that are being done. The key message that I would like to transmit here to you is that these improvements are certainly possible without or while maintaining the required performance and while supporting the operations. And what's also important is that thanks to the monitoring network, we can measure this improvement. So whenever there is a change done, we can compare the situation before and after and see if things are getting better as we deploy these measures. And in the long term, we of course have additional options at hand. So in the long term, we can talk about system modifications, upgrades of the sensors, radars, etc. We can talk about data sharing between centers, between sensors, and so on. We can also talk about new types of modulation of the transmissions, when you can then fit more information into a single transmission, which also helps, and many, many more. So that's it from my side for the introduction, and I'll hand over to Jürgen. Thank you.
Good day, everybody. My name is Jürgen de Klerk. I'm the supervisor of the surveillance department at SKYS. We are responsible for the surveillance infrastructure. First of all, I would like to repeat what Paul just said at the beginning of the introduction. That is that over-interrogation and certainly saturation of the frequencies that MODES is using can be quite dangerous. We know cases 2014 where an industry partner somewhere in Europe caused a saturation on the frequency and causing a big gap at MODES detection level, where ATC in that country was not seeing anymore any transponder information. Having said that, when you fly back this evening from Brussels Airport, I can assure you that you will be flying safe and that above Belgium, we are in a position to state that our air traffic control has good information, has good radar information, and that you are in safe hands. Oh. Okay. So what has happened in order to improve the situation? We have established a project team in order to identify the problems that we had on the 1030, 1090 with the help of EUROCONTRol, with the EMET tool that was established in 2019. We took this as a full project. Why? Because the complexity of the improvement was not so much lying in the technical improvements, rather the coordination and the validation activities, coordination with our stakeholders and validation with, first of all, our main client, Belgium ATC. We found and concluded two priorities within this change. First of all, we found out by measurements, and we had to develop new measurement techniques to try to find out inside the radar what was happening. We found out that certain aircrafts were highly re-interrogated. While the radar couldn't find or couldn't get a response, he kept on trying until in his mindset, the target was out of beam, causing for quite some traffic to be severely re-interrogated. Second of all, the average rate of the 1090 extractions. You have to know that Belgium is a quite small country. Today, we have our own surveillance infrastructure. We have no formal agreements with our neighbors. We are starting to establish formal agreements with our military partner. But that means that in order for our skies radar coverage, we are on ourselves to make sure that our ATC is having a good and a safe picture of aircraft on their screen. So that also means that our military are operating their own MODES sensors. That also means that we have two industry partners in Belgium who have a test site. They can also operate, use the frequency. And as you know, Belgium is quite small. We have 4 neighboring countries who also have their radars, with at least for some, quite some overlap in coverage. So also contributing to the frequency. Of course, we can't do anything by our neighbors. Our exercise lied in that to optimize our own sky sensors. If I can highlight some of the challenges that we had. First of all, because, as I mentioned during the introduction, for ATC, for everybody working in CNS ATM, we could not see the problem at first. It was not clear and not really, we were not conscious that there was actually a problem. It was only by identifying the fact that we were exceeding the minimum operational capabilities of a transponder that we were aware. And part of the challenge was also to raise awareness to those not radar-minded to prioritize this activity. I also like to refer to a famous British physician, Lord Kelvin, and it's mainly part of our validation. So when you can measure what you are speaking about and express it in numbers, only then you can start to say that you may know something about it. So key to our exercise was to quantize the SS and also quantize every improvement in the process. Safety change, often underestimated, but we have a quite high and heavy safety and change process before we can implement changes. And as I said earlier, we established a project team because it was key to us to have a very good coordination with all the different experts in the surveillance chain. With the radar surveillance, we are the first. We detect aircraft, but we are not the last. Within that chain, there are several other departments who will accept the radar data, who will track the radar data before it actually becomes available on the ATC CVP. Well, I won't go through all the project phases. If you allow me, I would like to highlight that an important one was the user needs. We tried to map the current user needs. So when I'm talking about user needs, of course, our prior concern is ATC skies, but we also have the military, we have the neighboring countries where we send radar data to, and we have MUAC, who has the airspace delegated from skies from flight level 245. So it was important to define the current user needs, which information they need derived from a transponder, but also the future radar needs from that transponder, this information. We cooperated with the radar manufacturer to find out together within the current envelope, let's say, of the current system, what we could do. We also established a process of improvement, which was, if I can call it, a sort of iteration. We didn't want to go for the revolution, but we wanted to go for the evolution. We wanted to validate each step in the process to make sure that we didn't lost anything out of sight, and that safety-wise, we kept on managing the safety, the performance, and for sure also the expectations of ATC. We use traffic of opportunity, we use simulations to validate the improvements. And we, of course, each time we monitored a validated compliancy to the ruling performance criteria. Some title missing. So the technical solution, as I said, it's the easiest, the technical part. We adapted the scheduling of the radar. Part of the job was also to develop new tools, new ways of measuring that what we do was safe, was improving the situation. We also reduced the time on targets, the pulse repetition frequency, so that the radar would simply have less possibilities to interrogate. These are radars dating from 2020 and some of them 2010. So you cannot just presume that they have the latest technology with the latest implementing rules on board. So we had to do it with what we had in terms of software parameters. So these were two of the points. During the installation of the radars 2020, 2000 and 2010, frequency and frequency saturation was not being discussed. It was not analyzed. So at that time, the radars were set up that we would get all the possible information from a transponder as often as it could, so during every scan. And with this validation process, together with ATC, we established a new extraction scheme, which the one that you can see here, in order to find a compromise between ops needs, where there was no additional latency introduced for our air traffic controllers, yet in order to optimize the situation. So to conclude, our solution lied in the combination of both, which helped to improve the situation. Yeah, this is, I go fast through it, one slide showing a new way of measuring. Inside the radar, what we configure is what is expected. As I said before, this exercise, we were not aware and we didn't have the tools to do that. More important is the analysis we did together with our ATM colleagues in the surveillance chain and together with ATC. Basically, we sliced up airspace, controlled airspace in different levels. Obviously, the lower you go, the less big amount of radars will still detect aircraft. So our focus was in the lower slice of the airspace, controlled airspace, where we tried to measure the latency of the extraction of all the parameters we do from our radars from the transponder. I'm just going to highlight the cleared flight level because for us it was the most important one to monitor. And I'm quite sure that also for you, many countries are using in their ATC center the cleared flight level as a check that when an air traffic controller gives instruction to the pilot cleared for flight level 100, that this message is accepted and returned via the downlinked information from the transponder. So our focus was on BDS 40, the cleared flight level, and we wanted to make sure that every step in the process, it would not introduce additional latency to the downlinked information of the new cleared flight level. It's a lot of figures. It's not the intention to go into the details. I wanted to only show you the quite heavy validation process in order to really make sure that, as I said, we measured the improvements, but also we could measure that everything remained quite safe. An interesting conclusion we found out that it's not so much the latency of the radar if you would reduce the extraction rates in the event of the cleared flight level, but it's actually the reaction time of the pilots, which is the greatest contributor to the overall latency, going from the air traffic controller to give the instruction to the pilot to inserting it into its flight management system, and the radar downlinking it up to the moment that the air traffic controller sees it. So we found out that what we did, we introduced a negligible latency, but that the biggest latency was anyhow coming from the pilots, which is a normal reaction. You can only accept an instruction, put it in, but therefore this conclusion. And as I said, we did everything in close cooperation with our ATC partners, so that along the way they were fully aware what we were doing, and they were also giving their their acceptation in what we have changed. So when we talk about the measured improvements, I guess the figure will speak for itself. What you see here is the peak messages, long modest replies, and the moment the statistic is lowering is obviously the moment where we have implemented our solution. As you can see, we are talking about averagely, let's say 75. We are going to 50, 55. I'm not saying that now we are there yet, but it's an optimum compared to our operational needs. And it's maybe heavy to state, but we also now have a new margin that we know that in the future we will have this margin till the moment where we are further deploying our roadmap, surveillance roadmap, where we decommission old sensors, we put in new, which will even increase performance and will have a better situation in terms of 1030, 1090 occupation. Another one, so this is before and after, before on the left, after on the right situation. The color code is not optimal. And again, it's not a claim that we have resolved everything, but as you can see here, we do have improved the situation. And it's again also here going to a compromise between possibilities and operational needs. Besides the direct effect of polluting the frequency less, there are quite some effects we have that cause, and it's actually quite normal, some additional problems which are not always clearly visible. For example, the collision of messages. When one radar asks for a specific information from a transponder, it responds, and another radar presumes it was for him and takes this message as the truth. We call it swaps. We also found out that actually this effect was severely reduced when we changed the scheduling. As you can see, this is a timeline in days starting from the 1st of January 2020, that's number 1, till the 30th of April, that's 120. So at day 20, we changed configuration on radar 1, day 52, radar 2, day 94 on radar 3. So besides the immediate effect of improving the frequency, there is also an improvement, which is obvious, indirectly in all effects that could contribute in a negative way, in this case, to a good detection of aircraft. So that was that. Again, this is just one small part. We have a surveillance roadmap. We are in the process to install new radars. We have decommissioned 2 years ago old monopulse radars. We are having a project for nationwide one. We are going to, in our roadmap, also implement ADS-B. So the process is not over, but at least it's a proven action we've done to improve our current surveillance infrastructure. Thank you.
Thank you, Jürgen. Thank you, Peter. We promised you we would go more technical, so I hope we didn't disappoint you on that angle. But I think what is made clear is that we cannot let this go unpathed. We need to work it. And yes, it's engineering, technical work, but the impact of not fixing it is an operational safety issue. It really is. We had this last year. We had in several places of Europe Dreamliners disappearing from radar screens. There's an EASA safety bulletin on this topic, etc. So this is a real operational issue. So please, in your respective organizations, give this the attention that it really needs. If no immediate quick question, I suggest that we move on. And then the next speaker is Gary. If he is in the room, there he is, yes.
Yes, good afternoon. Gary Bertz, dealing with navigation and spectrum matters. So it's my honor to talk to you about 2 other nasty little problems that are very technical, but affecting the digitalization, modernization, benefiting of operational benefits in our airspace. You see here data from our EUROCONTROL voluntary ATM incident reporting system that is managed by my colleague Dragica. What you see very clearly there, the red line is with GPS and the blue line is without GPS, that the GPS reports are actually dominating these kinds of reporting. The other good news that you see on this slide that we are not only now getting reports from the airline operators, but we are also starting to get more data from ANSPs. Now, when you look at the actual events, we thought back in 2016 when we had 400 or 500 events that was a high number. 2018 taught us differently. And then of course, COVID hit. And unfortunately, that was just a reduction in report. We have since turned to other measurement methods. So we have a cooperation with Airbus who very kindly report to us data from participating operators. They had 10,800 events in 2021. This year, this number has almost multiplied by 5, up to 50,000 events. And this is not all Airbus operators. This is only those that actually participate in the monitoring program. We get similar numbers from Ariane, They look more for the large area events, but they're not quite as dramatic. But the point out of the Ariane data that we see is, yes, we have certain hotspots in the Eastern European region, but we are not the only ones. Asia sees a lot, and there's no region in the world that does not have these kinds of events. And what you see now also is that in 2022, the number of events are bounding back up towards their previous high levels. What does it mean in terms of flight information regions affected? To make this slide very short, pretty much everybody that flies Europe to Middle East and Asia is flying through interference zones on an almost daily basis, and that can represent up to about 40% of European network traffic. Here you see the worry list. So here's the advantage of the pilot reports that we get. We actually hear what they tell us in the cockpit. We have spoofing question mark on the slide. In many cases, it's very difficult to distinguish the difference between what is potentially a misleading external signal being sent to the aircraft versus a simple side effect of the avionics integration in the aircraft. We know that the most significant safety risk that we have had occasionally, it's not many, but they are there, they are present, are false ground proximity warning alerts. And in a TMA, when a ground proximity warning alert goes off that is incorrect, what does it do? It coordinates, it can cause the crew to go full throttle and climb and execute an uncoordinated climb. So this is a safety risk that we are discussing actively with EASA, with the manufacturers, etc. You see here that this is a list of things that you really don't want to have. And so we have made some good progress to actually bring attention to this at the very high level. So we went to the ICAO assembly and we had a resolution agreed on this topic. We also spoke to the ITU. So this is the International Telecommunications Union. That is a United Nations sister agency to the International Civil Aviation Organization. And they've sent out a circular, which is the equivalent of a state letter. And at the assembly of ICAO, we did actually agree now to make interference detection and reporting a priority, such that you can see improvements in next generation equipment. The vision of this is that instead of, where today every modern communication system will have health monitoring built in, we don't have that in aviation yet for navigation and surveillance systems. So the idea is that the receiver tells us when it's getting interference rather than us having to guess, and that then a picture can be brought to the tech room that actually manages traffic. That is not something we can display to a controller. But I've just been in Tel Aviv. What they have happened there is traffic at 10,000 feet is still in an interference zone. They go for the ILS instead of the RMP approach. That means 18 nautical mile more in terms of track miles. And it also means that the guys behind them cannot fly the RMP approach because the guy takes time to fly the ILS approach. So we hope that this can operationally provide benefit in the future. In the near term, we have built up a capability that looks at gaps in ADS-B position reporting, and now have a network that builds on Petter's emit network that figures out where the interference zone are. And you see here the typical areas, but we also want to work further to add value-added data on top of that, which actually analyzes, okay, what is the terrestrial infrastructure coverage in this area? What are the flight plan capabilities? And with that, then how many aircraft are potentially affected that would need help from the ATC side? Unfortunately, we think that due to ongoing conflicts, this will be a problem that aircraft are simply exposed to because they fly high altitude. We're doing many things on this front, cooperating with many parties, putting things into the pipeline that the next generation avionics will improve, but unfortunately this will take time. And so in the meantime, we have these initial capabilities that we're working on, and also to mature the associated operational concept and the various interfaces. Okay.
Yeah, thank you, Gary. So again, to repeat, we have built up in the last couple of months, triggered as well through the Ukraine situation, now I would nearly say pseudo real-time capability in EUROCONTROL to see where GNSS interference is happening. We are reporting upon that every Monday afternoon in the 4 o'clock meeting. The issues are very among the areas, the geographical areas that Gary just showed on his slide, and we're always looking as well whether the relevant NOTAMs have been published or not. But we also frequently, and I would say 1 week out of 2 or 1 week out of 3, we're finding areas elsewhere in Europe where intentionally or unintentionally GNSS interference is happening. When we find this, yeah, we're always trying to get in contact with you to see what can be done about this. Please react then quickly and see what it is that you can do. And we will make available to you any relevant data. Again, it's a growing concern in Europe. It isn't likely to go away anytime soon. So again, we need to do altogether what we can to keep operations safe. With that, I again open the floor for 1 or 2 quick questions. If not, we continue on the path of fear, and we thank Gary first of all for his presentation. Yeah, clear and concise, and as we continue on the path of fear with cybersecurity. Patrick, Eric, the floor is yours. And I missed one. So I messed up. Okay, we also have more on the path of fear, which is the 5G.
Yeah, so try and make this quick. So a big milestone this year happened where RTC EUROCONTROL published a guidance document on radar altimeter RF interference rejection and tolerance. That's of course a mouthful. What the industry did is document best achievable performance with things that they can buy and put into the airplanes today without fundamentally redesigning a radio altimeter from scratch. That is, of course, not a new equipment standard, which is what everybody is craving, but it is taking time. If you want to take a guess, how many global experts worldwide are looking after radio altimeter technology? It's 20, 30, 40 guys that are doing this. On the European radio regulatory side, you see that 5G implementation is advancing in Europe as well. They want to do a compatibility assessment report, which is already late because implementation is advancing already. We've gotten delays, but the more delays, favors we get, that also means the more we need to deliver. Meanwhile, it's actually quite difficult to get the aviation guys and the radio regulatory telecom guys to talk to each other. They're not used to working to each other. Working with each other. They use different acronyms, different language, different procedures, different processes. Of course, it's not only driven by Europe, but also by things going on in the US. So the FAA has published a notice of proposed rulemaking, where first retrofits are actually being implemented. Unfortunately, the situation is that even after that first wave of retrofit, it is quite likely that a second or maybe even a third wave of retrofit might be needed. So this is very unfortunate in terms of forcing operators to invest in things at a time when it's not really a good time. Another thing that is quite significant in my view is that actually the reports of radio altimeter interference have increased following the first rollouts in the US. These are being very closely investigated. The problem is, of course, between a pilot saying, I see funny things on my radio altimeter, and actually linking that to 5G interference, that is quite a difficult problem. So we're not trying to raise more alert than necessary, but it is a concern that really needs to be worked, because at the end of the day, the radio altimeter is one of aviation's most sensitive systems, safety critical systems. This is just a little chart. Do I have a pointer? No. No, okay. So what you see is the 4.2, 4.4 gigahertz in the middle where the radio altimeter operates. You see existing ITU guidelines where the blue is a favorable aviation interpretation, the red, so there's differences of interpretation. The red is probably the better interpretation of an ITU recommendation that was established many years ago. Neither telecom nor aviation are terribly happy with that. But so you see here the improvement potential. And for those that speak the language of decibels, 20, 30 dB, that's a significant, dramatic improvement. The other thing that I would like to point out, though, is that as you see, once you go to 3.8 down to 3.0 gigahertz, that curve gets flat. So there is such a thing such as reasonable aviation filter rejection, filtering performance. Aviation needs to improve, needs to do better. But at the end of the day, there's also such a thing such as reasonable power levels. If you keep blasting out a lot of power for your telecom systems, then at some point it'll be, of course, very difficult to avoid interference with aviation systems that operate around 2 watts transmit power. So we did a think paper on this, some thoughts about how we look after spectrum. ITU has a treaty, the radio regulation. We are obliged to apply the latest innovations as soon as possible under that treaty. We're not doing that so well. We're being very good when it comes to like new engines that saves fuel and such, when it comes to getting new tech in CNS that just does what you can already do. That's a very hard selling proposition today. I'm not going to go into the details here, but the sector comparison that we did shows that aviation and telecom are of a similar size. So no, we're not small compared to them. But the moment you go to the ITU, we are outnumbered about 1 to 40. They have about 2,000 guys that liaise with their ministries of telecom. And you know, the aviation guys is really a small crew. And unfortunately, we are reaping the consequences of that lack of investment. There's no alternative right now on the horizon for something other than radio altimeter in the 4.2 gigahertz band. And so with that, unfortunately, low visibility operations actually remain at risk also in Europe. Now, deployment is possible, as several states have shown, if you keep transmit power around the airport at a reasonable level. But either way, we need to learn working better with telecoms, and we need to step our engagement in spectrum management. Thank you.
Thank you, Gary. So again, this is a message where we're looking at all of you. It will require serious effort from the whole ATM aviation community to further bring this to the attention of your state representatives, etc., the lobbyers left and right. This is not a quick fix either. But again, it's one of these areas where the problem is only getting bigger. And with the commercial interests from the telecom industry, again, we need to act. Yeah, even if we're all very happy to have 5G on our mobile as well. Yeah, so please take this home. Talk to whomever you can in your own organization and see what we can do all together. I'm scanning the room to see if there's any quick question. This is it, Gary? Yeah? No further mistakes on my side? There's a question. Sorry, please. I couldn't see you from here.
No problem, Paul. It's Michael Nachtigaller from Lufthansa. Question. Do we expect any update of the EASA guidance material on that? Because they have 2 years ago, there were several workshops, there are recommendations by EASA, and that's what we actually are following as operators. So is there any updates according to that plan, the new knowledge of the reports you have just explained here?
So EASA, I think they've published a safety information bulletin on this. The EASA standpoint is that at this stage, there's no data that suggests what they call the presence of an unsafe condition. And so their point of view is that at this stage, no regulatory enforced action like an airworthiness directive is necessary. And they're mainly in close cooperation with the FAA to coordinate on their notice of proposed rulemaking such that European operators will continue to have access to US airspace. So there's at this stage, nothing envisioned on the EASA side. That said, It's also a bit of a difficult territory in terms of who is responsible for what. Radio regulation is not EASA's responsibility. They say that themselves. It's the states that are liaising with the ITU. And so this is a radio regulation business that is not directly an aviation safety regulation business. So what will come out of individual states' rulings on radio regulations and what that actually means for airports, that is handled at the national state level. We see examples in France who are very active on this, who have installed protection zones around airports and such, but this is really left up to the state level. So there's a certain boundary also between what EASA will prescribe to the operators versus what then the airports will do locally, because that falls typically under radio regulation, which is not under the EASA remit.
But only to clarify that, so what we need are really specific normal EASA acceptable means of compliance or whatever in order to precisely describe us what we have to do or not. And there could not be, especially it's a safety issue, there cannot be a gray zone between EUROCONTROL and EASA to say, okay, that who is responsible for this situation. So we need one clear recommendation for the operators in Europe.
Yeah, so right now the focus is to work with the FAA on their notice to propose rulemaking and to make sure that in Europe everybody knows exactly that they know what they have to do if they want to keep flying in the US.
And also to be really 100% clear, there is absolutely no gray zone between EUROCONTROL and EASA on this topic. We work really well together on this topic. So again, we're all really trying whatever we can do. Jacopo himself is in frequent contact with the director of ITU, which again is not an easy man to get hold of, so to say. But yeah, it's a big thing which goes much wider than aviation. Yeah. Thanks again, Gary, and we swiftly move over to the Cyber Boys.
So hello everybody, happy to be with you. So together with Eric, we will share our views on what's happening in cyber. And I think what will be an important message today is that I would say all of you today, you have two roles. You have a role as being an aviation professional, but also as an individual, you have a role to play to support the aviation to be even more resilient. So here, this is a little bit what we have started to do, which is to derive the aviation threat landscape for 2022. So those data are mostly based on our own EUROCONTROL ATM cert data. We are just in the process of initiating the collection of information from stakeholders. Some are sharing it in real time. That's the ideal situation. I will come back on that. Others are sharing more, I would say, in a near real time, meaning once a year, which is good already. Last year, out of more than 2,200 events, 800 were coming from you. So thank you for that. So be aware that we will contact you soon so that you can share the events, the cyber events that affected your organization last year, so that we can publish a report that will help you to understand how aviation is subject to cyber attack. Why it's important? Because you can say, well, it's the past. Well, to a certain extent, we can use that information to know how we can be subject to cyber attack, because they may change maybe the technical aspects, but maybe the techniques, the tricks can remain for some of them nearly the same. So you heard about maybe some ransomware groups which are attacked, but don't be worried, some will take over. Huh? So this is really a business where they make something like 20 billion euros per year, all sectors, not solely on aviation. You can see that the main motivation is still financial, how to make money directly by stealing money or by publishing a website that is impersonating your airline. You do nothing. They just decided that, well, it could be a good idea to publish a website that looks like yours, and therefore tickets are sold, and of course the users never get the ticket. But sometimes it's data, and you know that the famous sentence, data is the new oil. Well, that's a reality. Huh? All information are worth some money. When they steal your email address, they can sell it to other guys who may launch a phishing campaign. So you receive some emails, and I will come back on that with concrete examples so that you can see the consequence. What is interesting also, on the bottom left, you can see a kind of purple bar, which is DDoS. distributed denial of service. This is a kind of attack where they use a lot of IP addresses to overload a server, and the server at one stage is exploding, not being able to follow the level of stress. Well, this is typically an effect of the war in Ukraine. Last year numbers were really lower than this level. Last year, there were some DDoS, some even having some critical impact, disruption of services. Keep in mind that we never had any report of a cyber attack having an effect on safety of flight so far, but on a provision of service, yes. So you can see that this number of DDoS has really increased significantly last year because of the war in Ukraine. You may have heard about many airports being subject to that. Eric will come back on specifically on this topic. So you can see that money is quite an interesting aspect. Aviation, we hold a lot of private data, which are really interesting for bad guys so that they can do something out of it. And also aviation is a way to be in the media. So you can quite interestingly convey some messages which will be relayed by the media. I don't know why people don't care about maritime, they are interested in aviation. So this is a bit the kind of threat landscape that we see. Ransomware, that's interesting. This number has a little bit decreased in the first semester because of the war in Ukraine. Why? Because some group of let's say bad guys were busy, supporting the propaganda and the cyber activities of the pro-Russian groups. Second semester, they're back to business. They need to make money. They have some objectives also. They are running like companies. They're organized, they're structured. When you are hit by ransomware, you will go to their website to start the negotiation. On average, the ransom is 5% of your annual revenue. And then it's up to you to decide whether you pay or not. Easy to say I won't pay, but you need to recover your service and you have some customers waiting for you. So that's the reality of what we face. Interesting is that that we are delivering some services to the aviation stakeholders of the EUROCONTROL member states. And I will take 3 examples of the kind of services we are providing to show you that cyber is something that is not only technology. There is a technology part, but not only. It's also people and processes, and that information sharing is important. So we have discussed about this anti-DDoS. So this attack DDoS, and some organizations have some solutions which are absorbing the bad traffic. They are called anti-DDoS solution. The problem is that most of the vendors claim that they have a certain performance, but you don't know. So as Eric, as a CISO, the problem is that yes, this kind of solution, and then is, well, when should I panic and when can I sleep well? So what we have done is, like hackers, we have developed a DDoS ourselves. We have found a telecom company accepting to host us. 6 months of legal discussions. You can imagine that they were willing to have confidence that we were good guys and not having bad intentions. Being an intergovernmental organization help for that. And now what we are starting to do is in full agreement and cooperation with you to test whether your anti-DDoS is performing to a certain level. So you will know what is the actual performance and not what the vendor is claiming. So that's a concrete way, you see, to help you to have a good level of confidence in your cyber resilience solutions. The second one is the phishing awareness campaign. We're offering a service to see how the staff, any staff in the organization, can react to a phishing email. I've just shown a slide where we did the test within EUROCONTROL. So behind the pie, you have something like hundreds of persons, and you can see that some clicked. Why it's important? Because that's where you see, remember what I said at the beginning, you have 2 roles as individual. Well, that's when you have a role not to click. And just to give you an example, this is really to raise the importance of the culture in an organization. Annette, you will be able to say to your father that after so many years, I still can't walk that carpet because we were clearly explained not to do so. Well, that's the kind of things you see that we also expect with these kind of things, is that, well, when you receive an email, if you have a doubt, just don't click, see? Whether it's an attachment, whether it's a link, well, think about it. Look at the actual email address. Is it coming from the name? Is it Patrick Mana and the actual email address is patrick.mana@eurocontrol.int or whatever? So there are certain things that we all have to do. We are all responsible for that. It's not the IT security. It's not only Martin who will do everything for us in the organization. So that's important. We can help you to conduct these kind of campaigns. And just a concrete example, we did it with a stakeholder. The 3 campaigns in 3 weeks. The first one, not so attractive, 20% of click. It was just a DHL parcel. The second one will be a bit more attracting. You have won whatever price, 50% of the people click. Third one, so 3 weeks in a row, super, very attractive price for holiday packages, 75% clicked. So you see that where we all have this responsibility to make our organization resilient. And the third one is what is so-called MISP. That's a service that we promote to share automatically cyber information. It means that not only you're saving resources, but also you are able to, I would say, be informed in real time. And time can be important. I don't know, you remember the Log4j vulnerability. It's something that happened in December 2021. You know, huge number of applications in the world, all sectors were affected by that. An aviation stakeholder was already attacked, someone trying to abuse the vulnerability 30 minutes after the vulnerability was disclosed. So we had to stop the service 30 minutes after the vulnerability was disclosed. This is a way to help us to be more effective by sharing information automatically. So improving the ability to update your security controls, but also in more real-time feature. So that's something on which we are quite strongly pushing, so that we have a community that is helping each other. That's really an important feature. What I wanted to address is this new common service that we're about to deploy, the European Aviation Common PKI. What is it? It's the ability to provide means to identify and authenticate your machines. So when you connect the computer to computer, well, you are sure that you are connected to the intended party. So this is a common service that we will offer to the aviation community. And the objective there is to show compliance with the regulation, so that we are CP1 regulation for swim in particular, but not only. So the ability is there to create a trust framework, a group of entities trusting each other. They will be part of the club, and then we will distribute these certificates to those willing to use that, to make sure that the machine to machine is connected in a secure way. It will be a user pay principle, so everybody will pay for the service they will use in a commensurate way. But of course, the users will be the ones steering the solution. So EUROCONTROL will facilitate it from a procurement process point of view and from a technical point of view, but the users will be the one managing it. This project now is about to become operational. It's the consequence or the aftermath of what was done in Cesar. Then in Cesar Deployment Manager, we had a self-co-funded project, and we have submitted the proposition to deploy it to the NDTech. It was supported. So we are starting with, I would say, a simple approach where we all work together using EUROCONTROL procurement process to make life easier. And then we learn from that once this is in operation to see whether we can go to another step, which is something where we derive our own requirements instead of using only commercial off the shelf. So we'll start slow so that we can learn, and then we'll see whether we can go to something a little bit more sophisticated where altogether we can derive, I would say, a more aviation dedicated certificates. But the most important is that we will be on time to be compliant with CP1, and we'll have a solution operational by the end of the year so that you can start to secure even more your systems. So this is the number of organizations which have declared an interest. EUROCONTROL should be added. They contacted me Wednesday. So we have something like 35 organizations, being air navigation service providers, airports, airlines, meteo, manufacturers, and of course EUROCONTROL. So this is the community we have so far, which has declared an interest, and till the end of the year, we'll work together to launch the call for tender, select the company, and initiate the provision of the service.
Thank you, Patrick. Thank you, Eric. We're running a few minutes over time, but again, it's the cyber threat is not one that will go away. It will only increase. Let that be a fact with the growing automation and digitalization of the European ATM system. What we can do at our level is work better together. And I think certainly, Eric, I think you've been very honest, very transparent. And again, we take well note of, we have a duty of care now, how we deal with this information, but to share the intelligence as things are happening in Aéroport de Paris, and very similar things are happening in the rest of Europe. Again, what we can do is work better together. So please all join in on this initiative that's on the screen, but also on all the other things. Let's please keep hand in hand and be, because again, in the end, we're going to be as safe as the weakest link in the whole European system. I look to see if there's any quick question from the audience. Yes, you're going to get lunch. I can tell you this already. Yes, please, at the back. Can you please state your name and organization?
Thank you very much, Mr. Chairman. Angelos Harlaftis, Epafos Advisors. We represent here Urania and Helios Space and Defense Group, a group which is working for the strategic autonomy of Europe for the last 12 years. So the question is about the cybersecurity, of course, is very important. The harmonization, which Nikos spoke, because harmonization is a very difficult word. And for example, the cybersecurity, do we, as Eurocontrol, we cooperate with EASA, with other cybersecurity organizations for the harmonization, because there are different types of harmonization. And about the communication of the VHF and the SATCOM, which we had, is there any upgrade over there? Because this gives us a kind of an advantage if we look at the strategic autonomy issue. So how is the strategical thinking of you about this autonomy? Because we have also white papers with cooperation with EASA and USA. Thank you very much.
So first of all, let me thank you very much for your questions. I thought there was more than one in there. So first of all, let me assure you that we work really hand in hand together with SDU, SDM, EASA, the Commission, wherever we can on this topic. ICAO, with FAA nowadays as well, on the trust framework setup at the global level. Yeah, we're very proud that we together with the FAA, we found a way forward on how to do things, etc. What I don't have for you is very quick, easy answers to all the different things that you've just asked. Yeah. By the way, if I can make some publicity, we'll also organize training events on cyber in our learning center in Luxembourg. But that aside, I would suggest that we take this offline during the lunch. Both Nikos, Patrick, Eric are fully available and can further go into detail on this topic. Yeah. I again look through the audience to see if there's any quick, easy question, or at least one with an easy answer. If not, then I hand over back to Tony. And again, thank you all speakers. Really appreciate it.